Today we're going to talk about the laws of exponents. So if we have x to the m times x to the n, when we have like bases, we add the exponents. So look at our numeric example. We have like bases. The bases are 3. We're multiplying 3 to the 15th times 3 to the 4th. So we add the exponents, and that gives us 3 to the 19th power. When we are dividing, we subtract the exponents. Now remember, we can only do this when we have what? Like bases. Here, our numeric example, 4 to the 9th over 4 squared is 4 to the 9 minus 2, which is 4 to the 7th power. Now in our last review of the laws of exponents, we have a power inside parentheses raised to a power outside parentheses. We multiply. So this is m, x to the m raised to the n power, which is x to the m times n. In our numeric example, 5 to the 8th raised to the 3rd power. If we were to write it 3 times, 5 to the 8th, 5 to the 8th, 5 to the 8th, we get 5 to the 24th power. Power of a product. So now we have a product inside parentheses and we're raising it to a power. Is x to the m, y to the m. So if a product is raised to a power, just multiply the inside exponents by the outside exponents. So this is 7 to the 4th times 2 to the 4th. Power of a quotient. You raise the numerator to the outside power and the denominator to the outside power. Our numeric example, 7 to the 5th divided by 3 to the 5th. Also, we are reviewing negative exponents. You can't have a negative exponent, so you're going to have to rewrite it as its reciprocal. So x to the negative m is 1 over x to the m. 5 to the negative 8 is 1 over 5 to the 8th. All right, so let's go ahead and get started. Well, you see here that we have 2 radicals. One's a square root and one's a cube root. So we have different nth powers. So if a problem begins with a rational exponent, just make sure you end with the rational exponents. Do not give me decimals and don't give me a radical unless otherwise specified. So we do have like bases, so we are going to keep the bases and we're going to add the exponents. So we're going to add 1/2 plus 1/3. We're going to go back and use what we learned back in 4th and 5th grade about adding fractions, find the common denominator. We're going to rewrite 1/2 is 3 over 6. We're going to rewrite 1/3 is 2 over 6. Now we can add it, and our final answer is 6 to the 5 over 6 power. See how we took a square root and a cube root and turned it into one root? Let's try it with number 2. Well, the issue with number 2 is we don't have like bases. So what are we going to do when we don't have like bases? Well, if possible, let's rewrite the base as a prime, or at least a smaller number. So we're going to go ahead and rewrite 27. 27 is the same as 3 to the 3rd power. And then we raise that to the 1/2 power times 3 to the negative 1/4 power. Remember, when we are multiplying, we're actually adding the bases. We're going to find a common denominator. 3 over 2 is the same as 6 over 4. And 1 over 4th is 1 over 4. This gives us 3 to the 3 to the 5 over 4 power. Example number 3. We have an expression on the inside being raised to the 2nd power. And what I noticed is that my nth root, they're both different. So we're going to try to rewrite 8. Anytime you can, if it's possible, please rewrite it as a smaller number or a prime. So 8 is the same as 2 to the 3rd power, all raised to the 1/3 power, times 2 to the 1/4 to the 2nd power. What we're going to do is we're going to multiply power to a power. So 3 times 1/3 gives me 1. And now what we're going to do, power to a power again. So now 2 to the 1st power raised to the 2nd power is 2 squared. 2 to the 1/4 power raised to the 2nd power is 2 to the 2 over 4, which reduces to 2 to the 1/2 power. We now have like bases. We can definitely add them. We're going to find a common denominator. 2 will be rewritten as 4 over 2. Now we have a common denominator. Our final answer is 2 raised to the 5 over 2 power. All right, let's try one with a negative exponent. We're going to have to see if we can rewrite 4 so that we can get a like base with 2. Well, this time I chose to multiply the inside exponents by the outside exponents, and this is a different way to start. So I have 4 to the negative 1 power times 2 to the negative 1 power. And when I simplify that, I get 1 over 4 to the first power times 2 to the first power, which is 1 over 8. I could actually show you another way to do this problem. And if you're interested in seeing that other way, just copy it down and come see me. For problems 5, 6, 7, and 8, for number 5 and 6, we're going to work through it together. And for numbers 7 and 8, you're going to do it and turn it into your teacher so she can see your processing. We're going to rewrite in simplest radical form. Simplest radical form. So it's telling us how to write it. We start off in rational form because everything is a ratio. Do take note that 2 is not to any power, so it is outside the radical. X is a cube root, so it's inside. And y squared, cube root, that's on the inside. Can we do anything else to this? No. Also note that singular, not plural, so you're not going to be able to give me 2 radicals. There we go. So now we have m to the 1/2 power and n to the 1/3 power. What we're going to do is we are going to find a common denominator. So we find a common denominator for 1/2, and it's 3/6. We find a common denominator for 1/3. It's 2 over 6. So we got 3 over 6 and 2 over 6. So we got a 6 for a common denominator. So here we go. When we write it under one radical, it is the 6th root. And m is to the 3rd power and n is to the 3rd power. How come we couldn't just add these together and say m to the n to the 5 over 6 power? You got it, because m and n are not like bases. Alrighty, so for our next two, go ahead and write those down. And in the end, you should write it in simplest radical form. Share that with your teacher so that she can check your understanding. And thank you for joining.